Given that this is true, show that it can be rewritten simply as tan x equals 3 root 3. Well, this is an addition formulae question. I can bring them out and then apply them. So in the first one, I'm going to be using the minus, and a is going to be x and b is going to be 60. So then I can write 2 times sine x cos 60 minus cos x sine 60. And then that is going to equal, I'm going to use the cos one now. So again, I'm using the minus, but this actually becomes a plus in these second lot of terms. A is now x and b is 30. So I'm going to get cos x cos 30 plus sine x sine 30. Okay, good first step. Right, so next up, I'm going to multiply it out to sine x and replace cos 60 by its exact value. You can use your calculator, you might know them. Cos 60 is actually a half. Don't worry if you don't know them. And then sine 60 is actually root 3 over 2. And then that will equal, do you know what, I'm going to try and fit this on one line now. That will equal cos 30, which is root 3 over 2, times cos x, plus sine 30 is a half, plus a half sine x. I'm tempted to like cancel out the half and the 2, but but the best thing to do now is just to times through by 2. So I'll get 2 sine x minus 2 root 3 cos x equals root 3 cos x plus sine x. Minus sine x from both sides and add 2 root 3 cos x to both sides. And then finally, just need to divide by cos x. So that is precisely tan x. On to part B. Hence or otherwise, really we should be using the hence. For 0 to 180 theta, solve this. I've got to think, how is that related to the original? So what I decided to do is, like, it looks very similar. I just said, right, let's let 2 theta equal x minus 60 and see what happens. If I find out what 2 theta plus 30 is, then that's going to become x minus 30. So you can see they are the same thing, essentially. So this implies that 2x minus 60 equals cos x minus 30, okay, with this substitution. I've learned 2 theta equals x minus 60, that's why I can just replace it here. I've shown that the 2 theta plus 30 is x minus 30. Okay, and this implies from A that tan x is 3 root 3. Now you can go ahead and solve in terms of x, and then get it back in terms of theta after. Sometimes I see people do that. This is like a temporary variable substitution, but I quite like to just keep everything in terms of theta, just so I haven't forgotten about it. So that means that x is going to be 2 theta plus 60, and I'm just going to solve it for that. So solve tan 2 theta plus 60 equals 3 root 3. Because I've also got to think about the limit anyway. So this is the limit for theta. If I double it, if I want 2 theta, then it's going to become 0 to 360. If I add 60, it becomes 60 to 420. Right, now I'm going to solve for 2 theta plus 60. Inverse tan of 3 root 3. Just remember, we're working in degrees here. Get your calculator in degrees mode if it's not already. So we get 79.106. Okay, just need the other solutions. You might just remember for tan that you just always add 180, absolutely fine. You know, there's no kind of symmetry properties. It's just, here's a point, tan repeats every 180. So I'm going to add that on. So that would give me 259.106. That's, remember, for 2 theta plus 60. If you're using cast diagrams, then because we've got a positive amount here, we'd put it here and carry it on. Should be a straight line, sorry. Okay, so we've got this angle as the 79.106. This is a straight line, so 180, so that's why, again, I'm just going to add it on to get the 259.106. I think we're asked if we write it to 1 decimal place. So I'll start with this one, minus 60, then divide by 2, gives me 9.553. Okay, below it, I'll then round it to, I always like to write it a little bit more accurately, just in case I accidentally don't round it correctly, or maybe I didn't read the question fully. Okay, I'm actually going to times back by 2 and add 60 to get back to the full answer. Add the 180. Right, and then minus 60 again and divide by 2. Don't do it all in one go. You should know this, of course. Put it in brackets, or I've been a bit lazy. I'm just pressing equals and then dividing by 2. 99.553, which gives us 99.6 degrees. Nicely done.